Morning everybody, and welcome to this webinar called Quality Engineering from Cradle to Grave. My name is Emma Hargreaves and I'm one of the managing principal consultants here at Ten10. Without further ado, it looks as though everybody who has registered for the webinar is online, so let's make a start. If you have any questions as we go along, please log them in the chat window and we'll get to them at the end. So what is this webinar all about? Well, before I get started, I guess we need to have a definition of what we mean by quality engineering. To my mind, quality engineering is more than just traditional software testing. It focuses on quality risk mitigation throughout the technology engineering lifecycle, left shifting quality practices and focusing on defect prevention as well as detection to build quality into the product from initiation through to decommissioning. The benefits of quality engineering over just testing can include increasing product quality, delivering to or even ahead of plan, I know that can be unheard of sometimes, and also reducing costs. This webinar has been written about pieces of work that have a definite beginning, middle and an end, where a team is put together to achieve a specific goal or a set of goals and then disbands once the goal has been achieved. These pieces of work include things like digital transformation, integrating digital technology across the business, changing how the company operates and delivers value. Programs of work that can be part of a digital transformation and are often wide-reaching and highly integrated solutions that comprise several elements delivered as interrelated projects. This could be the implementation and integration of a new tool within an existing digital estate, the replacement of an existing component of the company's IT estate, or a migration to the cloud, or many other programs. Or it could also apply to a single project, a self-contained project with little dependency on other projects or pieces of work, which could be the development of a new product, an upgrade to part or all of the digital estate. Whether it's a digital transformation, a program of work, or an individual project, they have a beginning, the initiation, a middle, where the project is delivered, and an end, where it gets transitioned to support. Although, actually, that isn't really the end. Support can and usually does continue for many years beyond the end of the initial project, right up until the point of decommissioning the solution. For the purposes of these slides, I will refer to all types of program or project as a project. So during these slides, I'm going to talk about three things. Firstly, delivery and quality challenges. What problem are we trying to solve? Then I'm going to talk about good practice, often referred to as best practice. We'll cover that in later slides, and also some common models for how to overcome these challenges. So without further ado, on to delivery and quality challenges. First up, delivery challenges. What are some of the common challenges that we all face when trying to deliver these projects? Firstly, the challenge and trade-off between the project needs and the day job. In-house teams trying to add additional workload to their already busy day jobs makes it very difficult for the project to get the skills and experience and time allocated to the work as needed. A skills gap. A new project often brings with it new technology, new tools, new techniques and approaches that people within the in-house team may not have the experience of using. The speed of business benefit. Day jobs and skills gaps can slow the delivery, delaying the business benefit and reducing the return on investment for the change. Business and domain knowledge. Understanding the context of the project, why it's important, why the change is being implemented, and having this specific domain knowledge is key to successful delivery, which often precludes outsourcing the program completely. The experience gap. So new projects bring new challenges and benefit from lessons learned from similar experiences, not something that all teams have access to. Often there's a challenge with siloed knowledge, so there's a strong tendency for the project team to hold the knowledge and not necessarily involve the support and business as usual teams. And also must remember that there's likely to be a future increase in business as usual workload. Another solution to support, and that means upgrades, maintenance, enhancements, more knowledge to acquire, increased integration and interdependency between different systems. And what are some of the common quality challenges that we face? So unrepresentative environments and data can be caused by a lack of understanding of the live estate or unscaled test environments, or even something as simple as not having integration to up and downstream systems. Small data sets can give the project team false confidence in the quality of the solution due to a lack of coverage provided by the testing, and undersized environments can give a false sense of doom when all of the load tests fail. Ill-defined requirements can cause significant quality challenges because requirements and user stories are the primary means of communication between the business stakeholders and IT teams. If the requirements are incomplete or not well defined or not well understood, the likelihood of misunderstanding and misimplementation and delivering the wrong product significantly increases. Close collaboration between business analysts, developers and tests reduces the risk of misunderstood requirements, but things like remote teams, siloed knowledge, different suppliers providing different roles jeopardize this. Not understanding quality risks and not communicating quality risks. Everyone wants to deliver higher quality software more quickly, but if you don't know what puts the solution's quality at risk, you don't know what actions to take to mitigate the risk. And we'll talk about this some more in further slides. Testing considered late in the process. So rather than think about quality, testing can sometimes be seen as a tick box exercise conducted at the end of a project. And last but by no means least, the word quality itself. It means different things to different people and different things to different projects. So project managers may be more focused on costs, business teams may be more focused on the number of features that they're going to get, whereas the budget holder might be more focused on the speed to market and the return on investment. It's important that all members of the project team know what quality means to the project and works towards that goal. So that's some of the high-level challenges that we all face when we're delivering these projects, but surely there must be some best practice to help us get through this. Well, to my mind, best practice implies one size fits all. There isn't any thought of the context and priorities of the particular project and that the solutions are simple. I wish there was a silver bullet or a magic wand or a handbook to follow, but unfortunately life's a bit more complicated than that. Where we usually end up is applying good practice. So good practice provides us with guiding principles, working out what's right for this project, building and layering small gains to deliver big results, something that can be adapted as the project progresses. What's right at the beginning of the project might not be right as you're moving towards the decommissioning of the solution. So what good practice can we put into place as we're thinking about project inception? Firstly, define what quality means to the project. Make sure that all parties know what they're aiming at. Is it speed? Is it low defect counts? Is it features and functionality? Is it some combination of all three? If so, what's that combination? This definition will underpin future decisions regarding priorities, timelines and cost. Identifying quality risks. Knowledge is power. If you don't know what is likely to threaten the quality of the solution, you can't take steps to reduce the impact or indeed remove the threat altogether. Capturing quality risks during inception and continuously managing them helps to engineer quality throughout the solution's lifespan. Defining a quality and test strategy and approach. Defining it early allows all team members to understand their part in the quality process. Things will change over the course of the project, so keep the document up to date as more information comes to light. Quality and test principles. It's unlikely that the project team will be able to anticipate every scenario that the project will encounter. Thinking about and agreeing your quality and test principles means that you have a framework to help you to decide what action to take when the unexpected happens. Quality advocates. The test team, while they play a very important role in quality, they're not the gatekeepers to quality. It is important that all team members play their part. So my recommendation is to find people who are passionate about the success of the project and the quality of the solution and empower them to advocate for quality throughout the development process and indeed the life cycle of the solution. Think about defect prevention as well as defect detection. Everyone knows that the earlier you find a problem, the cheaper it is to resolve. Fixing the wording on an ambiguous requirement is a lot quicker and easier and cheaper than finding the source of a bug, redeveloping and retesting the code. It will pay off in the long run to dedicate time to preventing defects at source, not just in requirements but throughout the development life cycle, rather than relying solely on detecting them during testing. And also think about the long-term support and maintenance of the solution. Don't make decisions purely on project priorities. Think about the solution priorities and the lifetime of the solution. Think about what will happen beyond the end of the project. Think about what the right decision is for the solution. Well, that strategic good practice is all well and good in theory, but what does that mean in real life? These next few slides will talk through a few examples of how I go about applying those strategic principles to the projects that I deliver. First up, lean documentation. So this presentation, I'm sure you've gathered by now, isn't a presentation on lean or agile, but what I mean by lean documentation is producing documents that are useful and valuable. Nobody likes to produce a lengthy document, 60-page document, you labour over it for days and days on end, then you send it out for review and hardly anybody reads it, let alone when you're 6 months into the project and something crops up, a risk that you've captured in your document that nobody read, and then all eyes are on you to say, why has this happened? I'd much rather focus on making a documentation useful and relevant. Nobody likes producing a document that's a tick box exercise. So what makes a document useful? I think there's several different reasons, but the key ones for me are first and foremost, making me, usually me, the author, but also the wider team, think about and agree on what's important. Sometimes when I'm doing test planning, just the very act of trying to write a test plan highlights all the gaps in my knowledge and makes me know that I've got a lot more questions that I need to find the answers to before I can actually go ahead and decide on the best course of action. Similarly, it makes the wider team members think about and agree on what's really important to them. Time and money are always fixed commodities on project delivery, and making the most of the time and money that you've got to focus on the right areas is important to everybody. Documents are also really useful for communicating the quality decisions that have been made. There's nothing quite like getting the decision written down on paper and asking people to sign up to it to make them realise that actually they've been thinking in slightly the wrong way. Documents are also very good for gaining consensus on the right quality approach. So I might propose an approach to quality that's completely at odds with what the solution architect is thinking or the risks that the development lead perceives there to be. So capturing this information in a lean document helps everybody to be on the same page, quite literally, with how we're going to approach quality throughout the project. It also helps to establish trust with stakeholders. Documents define what will be done and how, and it puts it there in black and white so that stakeholders can hold the project team to account with how things are going to be delivered. It also shows the stakeholders that we know what we're doing. Sometimes stakeholders aren't that familiar with IT processes, don't really understand what's going on in the project team delivery, but this is a key way of communicating with them and building that trust. So for documents to continue to be useful, it's all very well writing a fantastic document during project inception, but it needs to continue to be useful, and that means it needs to be kept up to date and relevant. And the longer the document is, the more perfect it is in terms of wordy, lengthy descriptions of things, the more difficult it is to keep it up to date as the project progresses. So my top tips to producing a lean document is to focus on getting the guidelines and principles right. These can be used to make decisions further down the line when everything's changed and is completely different to how we thought it would be at the beginning of the project. Those guidelines and principles give us a point of reference to make decisions on what we should be doing, not necessarily what we set out to do right at the start. They also, my top tip is to get buy-in from the project team, the wider project team and stakeholders to make sure they understand and agree with the contents in the document. It means we're all on the same page, we all agree the approach we're taking, the quality risks that we're focusing on, the quality risks that maybe we're not focusing on as much. Everybody is on the same page with agreeing that. Also think about using different ways of communicating the contents. So traditionally a Word document for a test strategy or a test plan has been used. Is that needed for this project? Would a PowerPoint do? Could a mind map be created that shows the key features of the quality approach? If there's somebody artistic in the team, could a poster be put together? Could the team collaborate and produce a poster that outlines the approach to quality risk mitigation? get everybody a bit creative when they're thinking about it. And also make the documents visible and easily accessible, so that can be on the shared drive, on Confluence or SharePoint, or if you do go for the poster idea, you can stick it on the wall in the office. So another example of putting theory into practice is capturing defect details. So I've gone from persuading you to produce your test strategy in a poster to talking about defect details, but bear with me. So one of the things that we've been talking about is making sure you can adapt and refine your test and quality risk mitigation approach throughout the project. But how do you know when to do that? How do you know when your approach needs to be refined? And capturing the right data and information when you log defects can be one of the tools to help you do that. So capturing data like the component the defect was found in, the root cause of the defect, the detected date and closed date, who detected the defect, all of that can be collated to provide you information to review the effectiveness of your quality processes throughout the life cycle. So in the simple example on this slide, you might ask yourself why component D has more defects than any other. Were the requirements poorly defined? Was the implementation more complex? Were code reviews conducted? What was the unit test coverage? Which tester was testing that component compared to the others? What techniques were they using? All of these questions and the answers to these questions give you insights into how well or how badly your quality processes are working and give you the opportunity to engineer fixes into the process so that all of your components are of the same quality. If the root cause for lots of defects is misunderstood requirements, or indeed a gap in requirements, then you know you need to focus more effort on that part of the process. If the root cause is test data, then there's work to be done to make the data more representative, etc. With the defect closure rate, so when the defect was detected and when it was closed and the time in between, if you're approaching go live, but your total defects are increasing and your total closed defects has plateaued, is the solution really ready to go live? Long-term product stability and maintenance is dependent on knowing that when you deploy fixes or new features, the existing functionality is unaffected. And how we do that is by regression testing. Creating a regression test suite that is lean, there's that word again, so not bloated and focused on the right areas, is key to confident deployments. These principles and what I'm going to talk about on this slide apply equally to an automated regression test suite, which you can listen and find out more about from some of our other webinars if you'd like more information on this. So in general, the content of a regression suite should consider things like the key features of the solution. What is the minimum feature set for the solution to work? What are the key features that need to be there every single day, day in, day out, in order for the solution to be acceptable to its users? Think about risk. Think about the impact of the failure. What things would have a large impact to the business or to the users if defects go undetected into live? But also think about the likelihood of failure. Which areas of the solution are most likely to introduce defects when they change? Focus time and effort on the things that will have the highest impact or the highest likelihood of failure, or both, so that you're targeting your limited regression test window on the right areas. Think about when new features should be included in the regression suite. At what point is a new feature a new feature? When is it ready to be included? Is it now part of the minimum feature set for the solution to work? When it gets to that point, make sure it's included. Also, think about frequency of change. Some areas most likely to change. These ones we're going to need more thorough testing more often. Make sure the regression test suite covers these features in detail. Think about defect clusters. Are some areas more flaky than others? I don't like using the word flaky really, but I guess we all use it during our project delivery. If you know you've got an area that's susceptible for defects, then they need more thorough testing every time you do a new deployment. But also think about feature obsolescence. Make sure you remove tests from the regression suite when they're no longer required. Talk about the regression suite being lean. It means when new features are added, we obviously need to include those, but as features get decommissioned or no longer required or no longer used as much or no longer likely to have as big an impact if they do fail, then think about removing them from the regression pack so you're spending time focused on the right areas. Having regular reviews and updates of the regression suite will keep it focused on quality risks introduced by changes, keeping the regression suite maintenance and execution efficient and retaining confidence in the solution. Thinking about the long-term solution, not just what's right for the project right now, but building that suite so that when the solution goes into support and business as usual, there's something there to make sure that the fundamental solution is working correctly. And my final slide on putting good theory into practice is around tools and metrics and reporting. So I mentioned earlier that knowledge is power. If you don't know what's going wrong, then you can't take steps to fix it. So in my opinion, information is at the heart of all test activities. The reason we test is to provide information and feedback about the quality of the solution to our stakeholders so that stakeholders can make informed decisions about the solution, whether that be reducing technical debt, changing development standards, making go, no-go decisions, thinking about where to invest more time and money, thinking about where we can reduce the investment of time and money because things are going well. But in order to do all of that, you need tools, metrics and reporting to support your test and quality risk mitigation activities to make sure you're focusing the right amount of effort in the right places and to make sure that you're getting the information that you need in order to make decisions. So producing reports with relevant, tailored and timely information allows stakeholders to make decisions with confidence. But in order to produce those reports, you need metrics that give insights into the quality of the solution. A bit of an extreme example, but reporting on the total number of tests executed doesn't give you the same amount of information as reporting on the total number of tests passed versus tests failed. The latter gives you much more information regarding the quality of the solution, but you can't do it if you don't capture the pass-fail details. Capturing and analysing metrics is much more difficult to do without the correct tools. Many tools come with default fields and workflows that give a good starting point for tailoring and configuring the solution to meet the specific needs of the project. The right tools allow you to link your requirements, tests and defects to give full traceability and coverage of requirements successfully delivered and those with issues. Again, empowering stakeholders to make decisions based on that information. Tools can allow you to produce progress reports and burn down charts to show your progress against the plan, giving project managers and people responsible for the time and cost of the solution information they need to know whether things need to be replanned and reshuffled. Can allow teams to collaborate on requirements and defects, giving email notifications of changes and updates to speed up progress to resolution, speed up answers to questions. The right tools can provide a repository of regression tests that can be organised and categorised for easy test selection and maintenance, something that can stay with the solution throughout its lifespan. And also tools can capture open and closed defect details with all stakeholders, including the business as usual and support teams, so that go, no-go decisions are made with full information to all parties, but also so that information and the metrics can be reviewed over time to make sure that the quality risk mitigation strategies you've put in place are working effectively. So far we've outlined some of the common delivery and quality challenges. We've also talked about some of the good practice that can be employed in order to address those challenges. Now we're going to talk about some of the common delivery models in order to deliver these projects. So this slide covers a few of the common delivery models that could be used to address these quality challenges. First up, in-house delivery. So in-house teams have excellent domain and business knowledge and also apply a long-term view to decision making because they're the ones who are going to support the solution after go live after all. So the project end date, whilst it's important, that's not the end of their involvement in the project or with the solution. But time and availability constraints, often coupled with skills and experience gaps, are likely to limit the progress that an in-house team can deliver for the project. Another option is to augment the in-house team with contractors. So this will plug the skills and experience gap. However, the sourcing and vetting of contractors takes time and focus away from the project team. And also contractors provide a short-term project-based solution. At the end of the project, they will move on to new things and the in-house team may be left with a bit of a knowledge gap when they've left the project. Another option is to engage a managed service provider or a consultancy. This will provide additional capacity and will deliver effective and efficient services without the need for the project team to source and vet the additional team members. With an interest in a long-term partnership, this service is likely to consider the long-term solution lifespan rather than just the project delivery, although the team will disband once the solution is live, losing knowledge without increasing the business as usual capacity. An alternative option is to use 1010's blended team consultancy and engineering services, which provide all the advantages of a managed service along with the certainty that academy engineers can remain with the solution beyond the end of the project, perhaps even to its grave, the solution's grave, not their grave. Providing quality engineering throughout business as usual support, maintenance and enhancement activities. Academy engineers are led during the project by experienced 1010 engineers, and the academy engineers develop their quality engineering skills as well as learn the business priorities and domain knowledge specific to the client and the solution. The academy engineers are a cost-effective way to deliver the project's goals, as well as providing additional business as usual capacity and quality engineering expertise beyond the end of the project. So, are there any questions? Although looking at it, we're just about out of time, so if you do have any questions, we'll look through the chat window and address those, and please email through any further questions quoting the title of the webinar and I'll get back to you with a response. Thank you very much for listening.